Hey, good morning. I'm glad to see one person, maybe a few people. So anyway, thanks for being here if you're here for the live stream. Week 14. Good morning, that one kid. Nice to see you as always. Thanks for being here. Um, yeah, so I know this is Thanksgiving week, but at Butte College, um, we take the Thursday and the Friday off, and we do instruction as normal otherwise. So we'll have a normal week in this class. I think everyone's got the routine. So um, don't forget that you have. Pardon me, I'm going to clear my throat here. Don't forget that the lowest two scores of your discussions and your labs are automatically dropped. So that gives you 2 weeks out of 17, which is a lot actually. So a little over 10%. If you just need to kind of deal with other things, then no sweat. You get two automatic drops of your lowest scores. So keep that in mind if you get yourself overwhelmed with other things you have going on this week, that you get those two freebies. Otherwise, it's a normal week. We'll have a discussion as normal. A lab is normal. And then the thing to be looking for now in the very near future is um, the distro project, because that's due in slightly less than 2 weeks. So please don't forget about the distribution project. Otherwise, we'll just keep motoring along. So I think, as far as I can tell, everyone's going along a-okay. If you're stuck anywhere on making decisions about the distribution project, Canvas Inbox, office hours, Piazza, those are all good places you can go and get help from me and or your classmates. So don't forget you have those extra channels of communication if you have questions about the distribution project. I don't really have a good measure of how like the average amount of time it would take a person to do. If it were me, I would leave at least an entire afternoon or entire morning open, say 4 to 6 hours. But probably I'd leave myself enough time to come back to it 2 or 3 times to make sure that my report's polished, that I have time to do extra research as needed, those things. So please leave yourself ample time. Just assume that it's going to take a lot of time, and if it takes less time than you think, well, then you're doing great. Good morning, Robo. Nice to see you. Okay, so that's where we're at, the distribution project. Please note, we are in the week of November 21st. The distribution project is due on Sunday, December 4th. So this coming Sunday is November 27th, the nearest one to us, and then December 4th. So you have slightly less than 2 weeks now to do the distribution project. Okay, so we are in week 14. We've only got the 4 to go, which for you guys is 3 weeks of content and then the week of the final exam. So we're not learning to be expert shell scripters in this class. I just want to expose you to some of the scripting functions, the scripting features of the bash shell. So some people made some really nice contributions to the discussion this week. One I can remember, for example, is that shell scripts are pretty portable. If you write a nice shell script for yourself in bash, it's a pretty good chance it's going to execute without having to make any changes if you copy it over to a different Unix or Linux system. So they do tend to be very portable. You can move them from system to system, and they'll work as expected everywhere. And they're very good for sort of collecting together sequences of commands. So you sort of have something that you want to work out how to solve a problem, and you have, a half dozen different commands that are kind of piped together or whatever it is. You solve this complex problem in the shell. You can use a shell script to capture that solution and sort of keep it forever in the form of a file. And then a bunch of other people, noticed in your research the different ways that system administrators like to automate tasks, commonly for things like monitoring users on a system. So you have a variety of ways you can monitor users on a system, when they last logged in, how much disk space they're using. You can actually, as a system administrator in a Linux system, monitor a lot about your users' activities on your system. unless they are clever and work really hard to make it so that you can't see their command histories. But there are workarounds to that too. Anyway, so I suspect that the system administrators kind of saw more quickly what the value of shell scripts can be. But even as a developer user, which is my main purpose when I sit down at Linux systems to write software, I still use shell scripts pretty often for collecting together sequences of commands that I use for project management and stuff like that. Okay, so this week we're going to just continue practicing with the echo statement. It's one of the more useful shell scripting tools that you have because you can print things from your shell script, which means that you can see what your shell script is doing as it's executing. Then we have the read command, which allows us to ask questions at the keyboard. And that can be useful even if you're creating a script for yourself. So you might have a script that says monitor which user's activity, and you type in the username. And then your user's name can be plugged into your script in a variety of places, and it can run all of the monitoring tasks that you want to run. We'll look at select statements. One of my favorite things in the Bash shell is the select statement. Kind of the auto magic menu generator is the select. We'll look at if statements and case statements that allow us to do decision making in a script. If you've had a basic programming course, then you've seen if-else type statements. Bash has those. If you haven't had a programming course, you'll see that we are able in our scripts to actually test conditions and then have the script do different things based on different conditions. One of the more technical things we'll look at today is the difference between comparing characters or strings and comparing numbers in shell scripts. So Bash is a little bit weird when it comes to comparing numbers versus comparing strings of characters. So we'll look at that. And then finally, we'll look at how we can actually use our shell scripts as kind of like little commands that we can feed information to from the command line itself, which is a super handy way just to, again, get more power out of your scripts. But we're not going to become scripting experts. I'm just introducing you to some of the sort of most important features of the Bash scripting environment, and then someday a scripting task will present itself to you, and hopefully you will remember that Bash has all of the things in it that you'd want a programming language to have, pretty much. It's quite nice. All right, so a couple readings. In the lab, I'm going to bring up my hands-on experiments, so I can come back to those in a second. So discussion is kind of a week off discussion, so you don't have to do research. You can just respond to a poll saying what you found most challenging so far in the semester. So the discussion this week gives me kind of one last chance in the remaining weeks to go back and review a little bit more purposefully things that people find still continue to be challenging or confusing. So anything I can do to kind of fill the gaps before we run out of semester, that's what I want to do with this poll this week. And then lab is always the discussion, which is a little bit lighter discussion since it's a poll. And then you have the distribution project, so please don't forget that. It's more than the normal amount of points. It's bigger, and it has a report attached to it. So please track the due date, December 4th, on the distribution project. Okay, before I switch over to the virtual machine, I'm just going to look at my hands-on experiments for the week. So you're going to see, pardon me, I'm going to clear my throat again. I don't know why I'm having that problem. Okay, so this is a script example. There are a couple of different ways to write if statements in shell script. So I'm kind of showing you both of them just so you realize that people use different styles in their shell script. And what I mean by that is, if you can see on the screen, the line that's numbered 6 says if space square bracket space quote payment and so on. So some people will use double square brackets there, and some people will use single square brackets. So you'll see both styles in my materials, just so you know they're both there. The other things when you're doing your own experiments is that the spaces tend to be very, very, very important. So there's a space on line 6 as an example. So if space. So when you see a space, when you're doing your own experiments, put those spaces there. Sometimes the spaces don't matter, but most of the time you'll discover that the spaces do matter. So if space, square bracket, space, quote, $ payment, quote, space dash LT, which is less than, space, quote, $ owed, quote, space, square bracket. So I'm kind of being dramatic about this because if you don't respect that spacing, weird things happen. So if you see a space in the samples and you're following along with the samples, you also should put a space and assume that they matter, and that if you don't put the space, something won't work right. Okay, so the second one is a little short one. It's a command line arguments experiment, but anyway, notice again on line 3, square bracket, space, $ hash symbol, space, dash NE, which means not equal to. So again, respect the spaces and you'll save yourself a lot of hassle. This one, they are hard to see, but I did put a note in here. So let's see if I can zoom in even further. I can, although they're still hard to see. Backticks. So people aren't used to typing backticks, and I'm going to type them in my live samples during the stream this morning. But this line 5 here, it says fixed day equals, that's a backtick. And the backtick is if you go to the upper left of your keyboard, you will find the squiggle, the tilde. The same key that has the squiggle or tilde has the backtick on it when you hold shift. So backticks matter in shell scripting and bash. I will use some backticks so that you can see these during the live stream, but I put a note here to call your attention to the backticks, which there's a backtick before the E in echo, and there's a backtick after the Z. And those have a purpose. What they do actually is, instead of allowing that command to execute, so instead of having the echo command execute and print to the screen, the backticks actually kind of capture what would have been echoed and then store what would have been echoed in a variable, in this case, fixed day. So you will see backticks in shell scripts when people are trying to capture a command's output inside of their script as opposed to letting the command's output appear on the screen. So that one has backticks. This one does not have backticks, but again, sort of just paying attention to the spacing. Where you see these giant gaps, by the way, those are tabs. So I have tabbed over. Technically, those are not usually required. But anyway, if you see spaces and blank lines and stuff, you'll just find that your life is a lot simpler when you're doing your own experiments. If you just do the same way that I do it to guarantee that they work. Okay, so here is just another one. There's not a whole lot going on in here. Line 5 on this one. So how do I know those are single ticks? I don't necessarily know those are single ticks, but when you're trying to differentiate in a script that you're reading between how do I know these should be backticks versus straight up single quote tick marks, backticks will have some command line utility in them. So you notice that other one had the echo command inside of it. This one has no command inside of it, like ls or date or calce or whatever. So the single ticks here are just kind of capturing the characters and not actually capturing the output of a command. That's subtle and it takes practice. Okay, but there's another thing that you can look for here. So notice that with the single ticks, it is dark pink. And then if we go to the next example, you see the sort of very faint pink. So those, and they're all commands. So those all have backticks on either side of them. So there's a backtick before the date, and there's a backtick after the A on the current day line. Backtick, 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 backtick. You can see kind of all the way down, and the color's a little bit different here to call your attention to that. So anyway, those things matter. The spacing matters. The backtick versus the straight up single quote, those are different and they matter in bash scripts. So please just pay attention as best you can to that stuff so that you minimize your frustrations when you are experimenting with shell scripts. All right, so I will unzoom that. All right, so just so you're aware of those things when you head into the hands-on experiments. And these scripts are here just so that you don't sort of find yourself wanting to do an experiment but don't have any ideas in your head about what you might do. Well, these hands-on experiments are here, and I might even use them in class this morning just to kind of help you do something on the screen and then kind of study what it looks like and what it does in a script. Okay. Yeah, so I think I can switch over to virtual machine. Yeah. All right. So make sure that you can see me on the virtual machine. So I still have my display manager, which looks like a login screen, but it's a display manager in Linux. We did this last week during the demos. The display manager is not only a graphical login, but it allows you to select your among your installed graphical environments. I have mine on Xface, although maybe I should play around with, I think it was it Cinnamon I thought was kind of cool. I'm going to try Cinnamon this morning and see if I think it's cool. Yeah, it looks all right. Okay, I think I'm okay with this Cinnamon one. Oh, and I like it because it has quick link to get the terminal up. I don't have to go hunting that down, so I'm actually pretty pleased with that. Okay, so I'm in my home folder. I'm going to make a directory for myself. This is week 14. And then I'm just going to build a few scripts and do a few experiments. So anyway, those of you who voted for Cinnamon, I like it. I might actually kind of switch over to it for a while and see what I think of it. Seems to run pretty good on my virtual machine, so no complaints so far. Okay, so I made a folder for this just to keep things separate. So let's go through the process and then we will add some new things. So I'm going to create a script. I will call it, I don't know. I was going to put a theme on it, but I don't have any good ideas yet. I'll call it my colors script. So this is a non-existent file, of course, so Vim is going to create it empty. I use .sh on my script names, even though they are not required. Linux does not care about file extensions like .txt or .docx or whatever. So you'll often see people in Linux systems putting file extensions because it helps them when they're looking at file listings remember what's what. So for me, when I see .sh, I know, oh, that was meant to be a shell script. Some people actually put .bash on the end of theirs, which is a good idea too. Either way, that way they can quickly kind of see if they have bash scripts as opposed to scripts written for other shells. But for me, .sh is fine. First thing we're always going to do is the shebang line. This terminal, by the way, I don't remember seeing this in the, I know for sure I didn't see it in the plain terminal. Anyway, quite interesting. So the shebang line, remember that's really just a guarantee that this script will be executed by the bash shell. And the reason why that is important to guarantee that this is executed by the bash shell and not one of the alternate shells is because if you are using bash specific features, then you want to make sure that bash shell executes your script with bash specific features, or things might not work as expected. Okay, so what do we have so far? We know echo statements. So that's just going to print. This is the script about favorite colors. I wonder, by the way, does this have themes? Let's see if this one has themes. Colors. Use colors from system theme. It does. I don't know which is easier for you guys to read. I feel like that one maybe is a little bit easier on the eyes. So there, just playing around with. This is the Cinnamon. This is the terminal that comes installed in Cinnamon. What terminal is it? It's the GNOME terminal. Okay, just a standard GNOME terminal. Okay, anyway, so I switched to a darker color scheme because I just prefer it. It's easier on the eyes. So anyway, echo statement, you know what that does. It prints stuff out. We can put a blank line simply by echoing a nothing, just with double quotes in it. So we'll do a favorite colors one. So we'll make a variable, secret color equals magenta. The double quotes there are not necessarily required, but it doesn't hurt. If in doubt, usually in a bash script, put double quotes. So the quotes around magenta aren't probably going to matter, but the quotes do matter when you have things with spaces in it. So keep that in mind. There's the secret color, and then we will do a read. Let's do one with the prompt. -p, and then we will, what is the secret color? Your color. Okay, so I have two echo statements, lines 3 and 4, which print stuff to the screen. Line 4 prints nothing to the screen, which is basically a blank line. In fact, if I want to be fancy, I'll run a clear command before my script starts, and that way it will just wipe the screen clear before it starts my first echo statement. So this is a script about favorite colors, and then I have a variable on line 8. Secret color equals magenta. That's just a place to store data, just like in any other kind of programming. Line 10, I am going to read something from the keyboard. The -p followed by a question, that is the prompt, meaning that's the question that appears on the screen that prompts the user to type an answer. And then the answer that they type will be stored in the variable your color. Now, let's see if they got it right. I think I did an if last week, but we'll type another one. So if, space, if in doubt, put a space. So you can put 2 square brackets here or 1 square bracket. Either of them works. I think the more modern style is 2 square brackets. But 1 square bracket is fine. Anyway, I'm going to try 2. Space. That space is important. So we will say if your color. And I put quotes around that because just in case they are being cute and put a space somewhere in their answer, if I don't use these quotes, I may not get all of their answer. I may just get everything up to the first space. So if your color. So when you are comparing strings in Bash, when you're comparing text with other text, like 2 colors, magenta versus whatever they type, when you are doing that, you use the symbols, and I'll type them out. But if you've had a programming class, then these will be the symbols that you're accustomed to for comparisons. Most of them, by the way, you'll be accustomed to from math class. So let me finish this thought, and then I'll go back and I'll put the comparisons. So comparing strings is different in Bash from comparing numbers. I'm comparing text strings. So I'm using this double equals to see if one piece of text is the same as another piece of text. another space, oops, close the quote, space, very important. I'm going to use the double square bracket style. You have to have a then, and this then can be at the end of the line or it can be on the next line down. I waffle on which of those I prefer. So the spacing is important. But anyway, what we're doing is comparing the color that you typed in on that read line with the secret color that we stored on line 8. And we're using the double equals because in Bash, that's how you compare two pieces of text to see if they are the same. And if they match, then we can say echo, you are correct. And then we can have an otherwise, an else. Sorry, the secret color is secret color, and then close the if. So I think we previewed an if last week. Here's an if. Your homework questions are going to show you a variety of scripts and ask you what their output is. So we just a few minutes ago looked at the hands-on experiments as things that you could practice typing out scripts to study how they work for yourself. The scripts that you will encounter in the homework or the lab questions this week, you can also type those in to your system and see and execute them. And that would also be a way not only to practice scripting, but also to guarantee that you got the exactly correct answer. Okay, so let's try this out. So I'm going to write and quit. And then I'm going to remind you just one more time about how all this works. So here's my color script. If I type colors.sh, it'll be command not found. Why? Because it is not on my big P path. So the folder that I'm in, which is the week 14 folder, is not a folder that the shell knows to look through for commands. It's not on my big P path. That's fine because I can tell the shell, actually it's in this folder. So the / means this folder, the file called colors.sh. And now the shell doesn't have to go looking for it. It knows that it's supposed to be here. So I don't get a command not found. I get a permission denied because they have to be executable. So don't forget to make your scripts executable so that they will run. So what's the secret color? Yellow. Sorry, the secret color is magenta. So that's all fine. Okay, so the shebang line inside the file, make sure it's executable, and remember that the folder that you're in is likely not on your big P path, which means that you have to tell the shell, hey, it is the script. Use the dot as the shortcut for the present working directory, or you could do the entire path to the present working directory. So that's my present working directory. So I could tell the shell, this is exactly where the thing is that I want you to execute. Works the same. But the quicker way to get to the present working directory is with the dot. So I'll just say in this folder, a thing called colors.sh, and it needs to be executable. So change mode, user plus X, your script. All right, magenta. So I got it right. Let's do a little scripty thing. So this is the same thing that you'll see in the hands-on experiment. So if I run this again and I say magenta, so it didn't match. And the reason why it doesn't match is because of the capital M. So one of the hands-on experiments shows you how to deal with this problem. The way that we would make the magenta with a big M, or if I were to run it again, if I'd spelled it this way. So the way we would do this, though, is we could echo that word and pipe it into the translate command, translating all the letters that are in caps to lowers. So that's the secret to converting something to all lowercase. Now we just have to capture that in our script. Okay, so let's go capture it in our script. So I'm going to read, and then after line 10 where I read in the color, I'm going to fix it. So fixed color equals, and then this is where I don't want to use that echo command and just have it print to the screen. I want to capture it. So I'm about to type a command that I intend to capture into a variable. So I'm going to backtick it. Backtick. I'm not sure what that looks like for you, but anyway, I'm saying it. So that's a backtick. It's find the key with the squiggle or tilde on it. It's the top left of your keyboard. Hold the shift key down, press that key, and you get a backtick. So backtick, and then what I want to capture with the backtick is that same echo command, although I'm going to use your color this time. So, and then I'm going to pipe it through the translate command to fix it. And then a backtick to close that out. So I'm going to fix the color that you type in by, with the backtick, echoing your color, piping it through the translate command, which will take all the uppercase letters and make them all lowercase letters. I will capture that in fixed color, and then in my if statement, instead of using the color that you typed, I'm going to use the one that I fixed up to be all lowercase letters, and now it doesn't matter how you spell it anymore. In theory, it should just work. So let's try it. So you are correct, because remember, it lowercased it automatically. Should work for any combination. Because remember, it's translating it down into all lowercase letters. So that's the backticks, and I wanted you to see those so that when you go back to the hands-on experiments, there's places where the backticks are being deployed, and you can pay attention for those. Yeah, so that one kid asked, so you still have to echo, use an echo statement to kind of force their data through the translate command, and yes, you do. I'm pretty sure if we look at the translate command, yeah, so the problem with the translate command is that it doesn't accept what you want it to work on the command line. You actually have to pipe things into translate by design. So yeah, that's a good question, that one kid. So for the translate command specifically, why won't this quit? There we go. You have to pipe inputs into it. So if you have just like one piece of data that you want to translate, you have to echo that piece of data into the translate command. So yeah, it's a good question. And for translate, you have to do it that way. There are some commands that will let you supply the data on the command line, but translate isn't one of those. So, and you'll see that's pretty common. So if you have a command that you need to feed data into, you can use the echo statement and the pipe to get the data into the command that you want to manipulate it. It's kind of a cool thing. Okay. So there's an if. What else do we want to do? What else is in my hand? Oh, we need to do numbers, comparing numbers. Okay. So let's do a numbers script. I hope you can. I've lost track of. Okay, you can. So the shebang line. And I'll have to remember to make it executable when I get out there. So numbers are a little bit different than strings. So let's just have let's just have this. So we'll clear, and then we will immediately read -p, enter a number. All right, so that much of the script will prompt them for and read in to the variable number. So now we're going to do an if statement on this one. So if space, and then we're going to see that comparing numbers is a little bit different. So instead of using things like the double equals or greater than or less than, greater than or equal to, less than or equal to, the bash shell, you have to do something special for numbers. So pay attention for this in my hands-on experiments and in the lab questions, so that you at least kind of get it in your head a few times that doing numbers in bash scripting is different from doing strings. So for doing numbers, we use a dash and then the question that we want answered. So we have as our options, in fact, I'll list them here. Number comparisons. We have equal to. We have not equal to. We have greater than. We have greater than or equal to. We have less than. We have less than or equal to. That's all the ones I can think of right now. So those weird things are how you compare one number with another in a shell script. So let's just say, for example, I am looking for ranges. So let's say that if this number is less than, and notice the spaces, so if it's less than 10, then, actually I like the thens, I think, right? Oops. I think I like the thens on the next line down. Then we'll echo number is small. And then we're going to add a few extra conditions. So this is else if, but in bash script it is typed as elif. So if the number is less than 10, we do one thing. Else if the number is, if it's not less than 10, maybe it's less than 50. Then and let's see, elif number less than 100, then large number, and we'll go for the super giant one. All right, so there's, and that's just so you can see in context the way we compare numbers as opposed to text or strings. So they have their own little special operators, dash EQ for equal, dash NE for not equal when you're comparing a number with another number, dash GT greater than, dash GE greater than or equal to, dash LT less than, dash LE less than or equal to. So I actually only used less than 10, or if it's less than 50, or if it's less than 100, or anything else. And then we'll try it with a few different inputs. So I need to make it executable, and then I will run it. So enter a number. I'll do a little one first. Should be a small number. I'll do less than 50, I think, was the next one. That's a medium number. Okay. And less than 100, so 99 would be less than 100. That's a large number. And then it's a very large number. So again, that's just to kind of show you some number comparisons in context. I mean, I could sit here and do whole bunches of scripts, but basically, in my opinion, at least, the best way to get a feel for these things is to type your own scripts. I've given you several examples on lab questions and in the hands-on experiments. See them in context, get the script working, play around with it, change the values, change what you enter, just so you can get a feel for how they work. Okay, so I got several more things to do, so I better get moving. Okay, that's numbers. All right, we'll do a case statement, then a select statement. Yeah, okay, so we'll do a case and then a select statement. Oh, I don't know. Um, Animals, I'll call it pets. So some other ways you can perform logic, and I should have put the command line arguments toward the bottom because I don't want to do those yet. Oh heck, let's do it. So the next thing I had in there is the command line arguments, and I'm going to kind of show you. We're going to build up to this over a few minutes. So Bash has the ability to handle you creating a script that you type the name of the script plus additional information. So I'm just going to show that here, how that works in Bash. So in Bash, I'll go ahead and clear this. No, I'm not going to clear the screen this time. There are some built-in variables. So this $hash or pound sign or number sign, however you say it, that's a special variable in Bash that tells you how many pieces of information were typed on the command line when the script was executed. We call those command line arguments, and let's just run it a few times to get a feel for how that $hash actually works. So what it does is it's a count of the number of the pieces of information you enter on the command line when you execute the script. So I'm going to save and quit that, make it executable, and then I'm going to run it. So text.sh. So I entered 0 arguments. So let's say dog, cat, fish. So 3 arguments. So hopefully you're seeing the 3 arguments are dog and cat and fish. I can do numbers. I can say hello. So that's 5 arguments. So what the shell is doing is it's taking everything after the script name itself, and it's counting how many things separated by spaces the person typed in at the command line. So why is that interesting? Well, it's interesting because we can then actually capture those individual pieces of information. So your first argument So the shell actually automatically numbers the arguments, and it doesn't just count them, but it actually numbers them and creates little number variables for them. So the first argument will get $1 attached to it. Echo your second argument, $2, and let's just stop it to. So we can see that the shell is not only counting the arguments that you placed on the command line, but it's actually assigning numbers to them down the row. So $1, $2, $3. As many as you ask it to get, it will get. I'm going to clear this time, so text.sh. So I didn't actually put any arguments, and notice that your first argument is just blank and your second argument is blank also. So now if I put dog here, so it counts dog and it assigns dog to the $1 magic variable. And since there wasn't a second argument, it just left that one blank. Dog, cat. In fact, I could say 100. So 2 arguments this time, and the shell assigned $1 to dog, the first one. $2 got the value 100 in it. So it's pretty cool. You can actually then get a lot more power out of your scripts if you want, simply by feeding them the information you want them to have, as opposed to asking questions with read statements. There is, by the way, one more magic one. The script itself is $0. So that usually is not super useful, but I'll show you the way that I tend to use it here in just a moment. So it doesn't count as a command line argument, but actually the bash actually creates a variable $0 where it stores the name of the script itself. So let's see what that looks like. So there's 3 arguments. So the script itself, notice, so it actually captured the initial command ./pets. And what's interesting is if you put the whole path here, that's how the shell captures it. So the shell actually captures the shell command part in the $0 magic variable, as I call it. And then all the other parts start at 1, 2, 3, as many as you have to give it, which is super, super cool. All right, so how do we use this information? So I'm going to comment these out. So if I put just a pound sign by itself in front of them, I disable them. I'm going to disable this one too. Okay, so the way we would often use this, so I'm creating a script where you have to give me the name of the pet. So if you have a script that requires information, requires arguments, you can actually use these variables to enforce that on your user. So I can say if the number of arguments is not exactly what I need, I need exactly 1 argument. So I'm using the number comparison. So I need the number of arguments that you give to be equal to 1. So if they are not equal to 1, I've got a problem. And what many of us will do is we'll echo and we'll just tell you, here's what you're supposed to be doing. Here's how you use this script. So we do a usage output. So if I don't get 1 command, I'm going to tell them how to use my command. So usage should be the name of the script itself. There I'm using the $0 to say that thing that you typed, that part's okay. But then I need a pet. And then I'm going to come back and improve this in just a second. So this guarantees that the user executes the script and supplies a pet name with it. So let's see how that looks if we run it. So if I run the script without any arguments, I get the usage output. Just a little handy reminder for the person running my script that, hey, when you run this script, you need to give a pet name. Okay, dog. So notice, okay, so it didn't detect that I was short my command. All right, so now we can actually go work with that part. So you can use the $hash thing when you need your user to supply information when they run the script. So you can check for that, and then you can spit out a nastygram saying, hey, you used it wrong. Okay, so this else part would mean they did it right. They put a pet name on there, and now I can do stuff with it. So what we're going to do here is we're going to use a case statement. We're going to check that first argument, which we have now guaranteed to be there. I think it's case in. So I'm going to use the $1 magic variable, which would be that pet name that they put on the command line, and then I'm going to respond. So let's say they say it's dog. Woof woof. That's all I got for that. So this case statement allows me in a different way to deal with the different possible outcomes. So case $1, $1 is the magic variable, which is the name of the pet that they typed on the command line. So if the pet that they typed is dog, I will echo woof woof. If it is cat, meow. And then the double semicolons are a way that I close off that section for dog. and then I close off the section. For cat, I'll go ahead and do a fish one. And then I'm going to do 2 echoes here. I don't know. I don't know what the fish can do. Okay, so in the case that the pet that they supply as their first argument is dog, I will echo woof woof. In the case that the pet that they put as their first argument is cat, meow. In the case that their first argument is fish, silently swimming, bubbles ascend to surface. And then we can do everything else. So anything else that's not dog, cat, or fish, we will say just a message just saying, well, whatever that is that you typed as your first argument, that's a nice pet. And then we close the case with the ESAC, kind of like we close the if with the FI, we close the case with the ESAC. So there's a case statement. It's just a different way of having your script do different things in different situations. Oh, I don't need to clear, so we will pets. Oh yeah, got to put a pet. So put a dog. There's the woof woof. Put a cat. There's the meow. Put a fish. There's the 2. And then finally I will put a bird. And then bird is a nice pet. So anyway, there's one with the case statement in it. I'm trying to be sensitive to our time. And using the command line arguments. So yeah, kind of one more major one, and then just a couple of a quick couple of standalone examples. So one word to look at, which is the select statement, which I think is kind of one of the more fun ones to do. Look, I'm just peeking over at the way that I gave this to you as a hands-on experiment. Yeah, okay. I can see a yeah, okay. So we're going to do that same script, but we're going to do it with a select statement instead. So another way, let's do so I'm going to copy pets.sh to new pets.sh. I'm going to check to make sure that new pets is still executable. It is. So when I did the copy, it came with its permissions. So now let's fix new pets.sh. And instead of having them type it from the command line, we're going to do a different style. So we're going to do a select. Well, let's just see what happens with this. This FI goes away. Done. Okay, so it's the same script, except for I'm going to use a select statement this time. So notice that I'm not checking the command line arguments anymore. So this new pets script doesn't use arguments at all, and I want you to see what the select does, because it's one of the cooler things in my opinion. Except for I forgot to fix the case statement has to use the pet. So the select statement kind of does an auto magic thing, which you'll see here in just a moment. It's cool, but it's hard to understand because you can't see how it does what it does. So the select statement creates a little menu and automatically kind of maps the menu to its outcome. So the select statement is going to print a little menu that says dog, cat, and fish. And I will select from that menu my desired pet, and then the case statement will respond accordingly. It's quite cool if I got it right. So new pets.sh. So that's the select statement that did that. It automatically numbered them. And when I type in my choice, it will automatically kind of map my choice onto that pet variable, which then the case statement responds to accordingly. Quite cool. The other thing I like about the select statement is that it keeps running. If I type 4, just nothing happens. And eventually I'll just Control C to kill it. So I think that the select statement is pretty slick. So it's a way to generate a menu. And you'll see in the hands-on experiments that I've given you a couple of other looks at how it can generate menus, because you can actually use a select statement to generate a menu off of like a listing of files, and you'll see an example in the hands-on experiment of that. So anyway, when you see a select into bash shell, it's a fancy way of auto-generating a menu of options, and I love it. I think it's really cool. It's quite a neat feature. Okay, so down to the last couple, and one of them I'm just going to use the man page to introduce you to. So I have one kind of just interactive the example I'm going to do from the command line itself. So we know that a read statement without any kind of prompt with it, so it's just read first input. What it's going to do is sit there and just wait for someone to do an input. And now I can go and I can see that it actually read my input into that variable. We also have the read dash p. Day is Monday. I could do it with a prompt, and then I can echo the day, and there's the Monday that I typed in. So one more of those is the read dash s. So the dash s reads it in secret. And what does that mean? So watch when I type. So the dash S option actually makes a silent read where the characters aren't echoed on the screen, which is a security measure. So I did an input. Let's see if it was in there. So the data is still in there. Oops, I typed it wrong. That's the number that I typed. So the dash S is kind of cool because you can actually write a script where some semi-sensitive information is typed in response to your script without someone shoulder surfing you, looking over your shoulder and reading your secret information. And you can combine all those up together and say, make a secret read on a prompted one. All right, so there's the prompt, but notice it's going to be a secret read. So so it's in there. If I echo it out, there's my secret passphrase. So anyway, something that you can play around with if you find yourself sort of interested in working on your shell scripting skills. I like the secret read for potentially sensitive information, kind of like when you log in and it doesn't show what characters you're typing or even that you typed any. Okay, last thing. I'm really just going to do this as a man page. So I think multiple people kind of mentioned the idea of monitoring a user's disk usage. There is a command for that. It's called du, disk usage. Um, and it's an interesting one to experiment with if you are a system administrator type and you're sort of imagining that you might create a script someday to monitor your users in terms of how much disk space they're using. There is an option in here that I like. There's the -c, which is a grand total. I think that's useful. The -h, human readable, is useful. So I'm just going to do a quick use of it. But anyway, this du command is useful for creating user monitoring scripts because it lets you see how much disk space they're using. The basic is that you just type, I think the, wait, what was the argument I'm supposed to type? The location. Okay. So the location. So if I go to my home directory and I disk usage that directory, then it will kind of dump out everything from here on down the tree in terms of my disk usage. These numbers are in bytes. So one of the things I like to do is add the human readable switch, which is helpful because then you can see, you know, where like megabytes are coming up, where things are just in kilobytes. And then finally, I also like the, let's see if the, let's produce a total. And then let's produce a human readable total. So it still shows you everything, but it also gives you this total at the end that's human readable, and that's handy to know. So anyway, it came up a few times in discussion this week that monitoring disk usage could be a useful thing to do in a script. And the command to do that specific monitoring is the du command. So there are others, but that's one that I've used many times in the past when I've been on the sysadmin side a little bit. Okay. 904, I think that is, oh wait, I did have, I've already gone over this, but anyway, just to leave this in your heads, where I talked about it at the beginning of the live stream when we started looking at the hands-on experiments, and then I also talked about it when I used it. So pay attention for the backticks versus the single quotes versus the double quotes, because those things matter. Also be mindful of the spaces when you are doing your own scripting or you are using my examples from the hands-on experiments or the lab. And then also be mindful of the spelling, which is the one that gets me the most often, is just misspelling things. So anyway, have kind of a checklist. Did I spell things correctly? Did I space things like I'm supposed to space them? Am I using backticks where they need to be used, or did I accidentally get a single quote, single tick, regular up and down tick in that spot? So anyway, that shell scripting is awesome. It's fun to do. You can quickly get kind of interesting results. You can use all of the commands that you use at the command line to build out shell scripts. I love all that stuff. My main complaint about shell scripting is that it is very touchy and very sensitive about spaces and symbols, and so anyway, just be on the lookout for those things, and hopefully that with me going on and on about it, that those things won't get you stuck when you're doing your own experiments. Okay, so that's it for me, for you guys, for this week. This is week 14. Next week is 15, so we have 2 more weeks of new material, and then we have a review for a final exam. And then the final exam week, don't forget also the distribution project is due on December 4th. So I'm available as always on Canvas Inbox, on Piazza, or in office hours. Although this week I'm going to move my, I'm going to do a minimal office hours maybe on Friday afternoon. So presumably everyone understands why, but Anyway, if you are doing anything on Thursday for Thanksgiving, please enjoy that. If you are taking the time to get some extra hours at work or just to get caught up in school or whatever it is, I hope you have a great week. And I will see you on Monday morning next week. Yeah. So take care in the meantime.